Welcome to the Check Your Understanding for 10.2b. So we have an experiment with randomly assigned students into two groups of 10. Each student in the first group drank 12 ounces of cola with caffeine. Each student in the second group drank 12 ounces of caffeine-free cola. All students then measured their pulse rates again. The table displays the change in pulse rate for students in both groups. Even though you do have these two measurements, I want to point out this is not a matched pairs experiment. It's not like they match two equally matched people to get the treatment and to not get the treatment. So you have these data values, and then the mean is taken, and we will look at the difference between these two means. So just note that. I still have two unique groups. We are going to construct and interpret a 95% confidence interval for the difference in true mean change in pulse rate for subjects like these. Since it wasn't randomly selected, we can only make our conclusions to subjects similar to those in this experiment who drink caffeine versus who drink no caffeine. So anytime you are asked to do a confidence interval or significance test, we need to go through state, plan, execute, and conclude. So state, we need to define the parameter. Mu sub 1 minus mu 2 is the true difference in the true mean change in pulse rate. So that's important. It's like the mean change, how much the pulse rate changed. It's not like just the final pulse rate, but a change in pulse rate. And it's caffeine minus no caffeine. And if you want to use labeled subscripts for that, that is fine. So we define the parameter, and we need to say the confidence level, 95%. And then our plan, we will name the test. If you want to help remember that, we can panic parameter. Level. Oh, that's not in there though. Name. Assumptions. So the random condition is met. The treatments were randomly assigned. We will have a approximately normal sampling distribution. We don't know that the populations are normal. We don't have enough data to use the central limit theorem. We have less than 30. But if we graph the data, and yes, you need to provide a graph of the data, you have only these 10 values. Make a quick dot plot. Make sure you label your dot plot. Change in pulse rate, final pulse rate minus initial pulse rate. And these are the values. So it looks like caffeine had a higher maximum, but of course we'll see if the difference in the two sample means is surprising. Now be careful to use past tense when you talk about the parameters in an experiment. There's an interesting detail. So the true difference in the true mean change in pulse rate, caffeine minus no caffeine. Notice how that's kind of present tense. So just be careful with that. You will get marked off on rubrics for that. And then the reminder, we are not checking the 10% condition because that only applies when a sample is randomly selected without replacement from a population, and these subjects were not selected at random. And here's a screenshot of an old AP rubric where they marked a response as essentially correct if you included these three components. Identifies the correct test procedure, the name, checks for random assignment to treatments, and checks for normality. So no 10%. Okay, now let's execute. Here's our general point estimate plus or minus margin of error, the specific, and then here are the values plugged in. Here's our difference in sample means. Here's our T critical value and our standard error. And then there's our interval and our conclusion. We are 95% confident that the interval from negative 1.491 to 3.891 captures the true difference in mean change in pulse rate, caffeine minus no caffeine.